Hello everyone, welcome to my YouTube channel. As you know that we have been solving the unsolved numericals of NCERT Physics Part A for class 12. So in the same series, today we will be taking our next lecture, that is lecture 4 of unit 1. So without wasting much time, let's continue directly. So till now, in the previous 3 lectures, as you know that we have solved the first numerical in our lecture 1, then second numerical in lecture 2, third numerical in lecture 3. All these 3 numericals are already solved, as you know. Today I will not take directly 1.4 and 1.5 because 1.4 and 1.5 they are the conceptual questions and I will be sharing their answers directly on the description. They are just the theoretical concept, need to explain directly with the theory. So I am directly taking question number 1.6 of our first unit of physics NCERT part A. So today I will be solving question 1.6 in my lecture 4. So let's start directly. So let's start. So this is our unit 1, that is electric charges and fields. So the question number 1.6 of unit 1st of physics NCERT, it goes like this, that question 1.6, 4 points charges QA equals to 2 microcoulomb, QB equals to minus 5 microcoulomb, QC equals to 2 microcoulomb and QD equals to minus 5 microcoulomb are located at the corners of a square ABCD of side 5 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? So now let's understand the question first. It is given that we have a square. This square is say A, B, C and D. You see this figure. We have a square ABCD having center at say some point O. This is the center. I have drawn 2 diagonals and we have a center at O. First try to visualize the problem, then it will become very easy for you to understand what exactly I mean to say. So we have a square ABCD. This ABCD has equal length. AB and say BC both are of 10 centimeters. It is given in the question that the charge at A is 2 microcoulomb. The charge at B is minus 5 microcoulomb. The charge at C is 2 microcoulomb and charge at D is minus 5 microcoulomb. So from this figure you can understand that AB, BC, CD, AD are all equals to 10 centimeter. The question is asking what is the force on the charge of 1 microcoulomb placed at the center of the square. That means they are saying that at the center we have a charge of positive 1 microcoulomb. You know that 1 microcoulomb, or we can say micro, it is equals to 1 micro, it is equals to 10 raised to the power minus 6. So as I have been saying again and again in the previous few videos, same I will be repeating that when the charges are of same nature, that is say it is A is positive and O is positive, they will have a repulsive force between them. Similarly, if we say between B and O, it will be negative positive, that will it will be have attractive force between them. C and O positive and positive, that is repulsive. In the same way between D and O, O is positive and at D it is negative, it will have attractive forces. So what is asked in the question is what is the force on a charge of 1 microcoulomb placed at the center of the square? That means we need to find the net force at point O. Yes, this has been asked. You know that this AB equals to BC equals to CD equals to AD. Yes, now when we are considering the charge between A and O, we can say that force will be a repulsive force. So force between A and O will be repulsive, yes, and its magnitude is equal to the force between O and C. Yes, we can say that the force of repulsion between charges placed at A and O is equal in magnitude. Yes, that means force AO will be equal in magnitude to the force between CO. Yes, both are repulsive, have certain magnitude, but their magnitude will be same, so they cancel each other. Sorry. In the same way, between D, you can see here, between this D and O, one is positive, one is negative. So force between D and O due to charge at D and O will be equal in magnitude to the force between B and O due to charge of -5 microcoulomb and 1 microcoulomb. So they will also cancel each other. So we can say that in the way in which A and O and C and O are equal in magnitude, in the same way force between D and O and B and O are similar in magnitude but opposite in directions, we can say. So they cancel each other. So in nutshell, what I mean to say is, finally A and C cancel each other at O. Similarly, B and D cancel each other at O. So overall force which is asked in the question, that is, what is the force on a charge of 1 microcoulomb placed at the center of the square, it will be equals to 0. So in words I will be explaining, like try to understand in words. We have this problem, yes, in which A, C, B and D are the sides of the square and everything is explained. So what I mean to say is, force of repulsion between charge placed at corner A and center O at corner A and center O is equal in magnitude but opposite in direction relative to the force of repulsion between the charges placed at corner C and center O. Hence they will cancel each other. That means this force will cancel this force. In the same way, force between charges placed at corner B of -5 microcoulomb and center O is equal in magnitude but opposite in direction relative to the force of attraction. Why attraction? Because they are of opposite nature. Here it is positive 1 microcoulomb and here it is negative. Attraction between the charges placed at corner D and O, that means this one and this one. Hence they will also cancel each other. Therefore net force caused by the 4 charges placed at the corner, these 4 charges placed at the corner of the square of 1 microcoulomb charge is 0. Hope you understand. So what the question is very easy. All you need to do is you need to make your concepts the way I am saying. Very small things that are repetitively been saying, that equal charges with same nature repel each other, charges with same opposite nature attract each other. That is the concept in this particular question. So hope you understand. Try to solve it once again. You will find it very interesting, and if you have any kind of doubt in any of the questions, as I'm been saying again and again, so we can solve those questions separately also, or I can share you any details you want. So thank you very much. For any queries related to your numericals in NCERT physics class 12th, you can mail me at gaganbansal12345@gmail.com. So see you in the next class with the next numerical. Thank you very much.